Hello everyone, we continue with trigonometric ratios for any angle between 0 and 360. Now we are going to look at, this is video 3, and we are going to look at coterminal angles. Coterminal angles have the same terminal arm. So what do we mean with that? So let's say we have a 30 degree. So 30 degree is an acute angle and it is going to be in the first quadrant. Okay, how about if we draw 390 degree? So 390 degree, so we start from positive x-axis, so this would give us 360. We need to go 330 degree more. So as you see, we end up with the same terminal arm. So 30 degree and 390 degree have the same terminal arm. How about if we sketch negative 330 degree? So this time we start from positive x-axis and go clockwise. So this is negative 90, negative 180, negative 270. Oh, we also end up in the same with the same terminal arm. So this is negative 330. So those three angles have the same terminal arm. Therefore, they are called coterminal angles. Those angles are not the same angles. However, their trigonometric ratios are the same. So sine ratio, cosine ratio, and tangent ratio of 30, 390, negative 330 are the same. Okay, so let's give another example. So let's say we have 100 degree. So how can we find other angles that are coterminal with 100 degree? I can actually add or subtract 360 degree to find other coterminal angles. Okay, so if I add 360 degree to 100, so that gives me 460. So 360, so 100 more gives me 460 degree. So 100 and 460 are coterminal angle. Or I can add one more 360 to this. So 460 plus 360 gives me 820. So if I sketch 820, so I start from here. So I need to go 360, 720, and 100 more. So I also end up here. So 820 degree will also have the same terminal arm. So 100 degree, 460, 820 are coterminal angles. Also, you can subtract multiples of 360 and they would also give you other coterminal angles. So let's say 100 minus 360 is negative 260. If you were to sketch it, so you would go this way, and that is negative 260. Again, those coterminal angles are not the same angles, but their trigonometric ratios are the same. Now we can look at our example 3. So we have theta being 50 degree, and it says find two angles, one positive and one negative, that are coterminal with theta. So again, if we write the formula for coterminal angles, so we can say that we take theta and we add or subtract multiples of 360. So if we say that k is an integer here, okay, so k is an integer, so you can, let's say put 1, so you add 360 to theta, or you can put 2 for k, so then you add 720 to theta, get a coterminal angle. Or you can substitute negative 1 for k, then you subtract 360 from theta. Okay, so to get coterminal angle for 50, okay, so let's say we want to get a positive 1, so we can add 360 to it. So that gives us 410 degree. Or we can subtract 360 or any multiples of 360. So in this case, I have 310 degree. Okay. So those are again 410 and negative 310 are coterminal with 50 degree. So let's look at B. So theta is negative 100. So to get a coterminal angle, again, I'm going to add or subtract 360 or multiples of 360. So let's add, in this case, 2 times 360. So that gives you 720. So that gives you 620 degree. Or you can subtract 360. And that gives you negative 460 degree. And you can find infinite number of coterminal angles, okay, by adding or subtracting multiples of 360. So let's look at example 4. It says evaluate tangent 510. But that 510 is not between 0 and 360. So therefore, actually, you need to find a coterminal angle to 510, and that we want that coterminal angle to be between 0 and 360 to be able to calculate. So the first thing, you can add or subtract 360 to 510 to find an angle that is between 0 and 360. So in this case, how about if we subtract 360 from 510? So that gives us 150. Okay. Again, we know that coterminal angles have the same trigonometric ratios. So tangent 510 is equal to tangent 150. So if I get tangent 150, so I can calculate tangent 510. Okay, so let's then sketch 150. Okay, so again, this is 90, this is 150. If you were to draw 510, so that would be, so you go 360 and 150 more. So draw, this would be 510 degree. Okay. Then find related acute angle, beta. Again, I'm going to use 150 when calculating the beta. So 180 minus 150 gives me 30 degree. So step 1, sketching the angle. Step 2, finding the beta, and that's what we got. Step 3, write the trigonometric ratio of the related acute angle, tangent 30. So we can again use the special triangles. Okay, so that gives us 1 over root 3. Right. So now we can write the ratio for tangent 150. So we know that the numerical value is going to be 1 over root 3. Then we need to decide if we need to put a negative or positive sign here. So we write cast. So we are in quadrant 2. In quadrant 2, sign is positive, tangent must be negative. So tangent 150 is negative 1 over root 3. Or if we rationalize it, we get negative root 3 over 3. Okay. So since tangent 510 is equal to tangent 150, then tangent 510 degree is negative root 3 over 3. So let's look at part B, cosine 495. Again, this angle is not between 0 and 360. So we need to find a coterminal angle that is between 0 and 360. So we can subtract 360. So then 495 minus 360 gives you 135. So I know that cosine 495 is equal to cosine 135. So I can sketch 135. So this is the first step. Step 2, find beta. Beta is 180 minus 135. So that gives us 45 degree. Step 3, find the trigonometric ratio for the related acute angle. So we need to find cosine 45 degree. That is 1 over root 2 or root 2 over 2. Then step 4, use cast to write the ratio for the angle. So cosine 135 is, so we are in quadrant 2. In quadrant 2, so sine is positive, cosine must be negative. So negative root 2 over 2 we have. So therefore cosine 495 is equal to negative root 2 over 2. Next one, sine 600. So same idea, 600 is not between 0 and 360. So you need to find the coterminal angle that is between 0 and 360. So let's subtract 360 from 600. So that gives us 240 degree. So I know that sine 600 is same as sine 240 degree. Again, 600 degree and 240 degree are not the same angles, but sine of 600 and sine of 240 are the same. So then sketch the angle. Step 1. So 240. We are in quadrant 3. Okay, so find beta. So beta is 240 minus 180. So that gives us 60 degree. Step 3, find the ratio for related acute. Sine 60 is root 3 over 2. And use cast to write the ratio for sine 240. So in quadrant 3, tangent is positive, sine must be negative. So we get sine 240 equals negative root 3 over 2. So therefore, sine 600 is also a negative root 3 over 2. Okay. So next topic, quadrantal angles. Before we do that, I want to go back and talk about a point on a terminal arm again. So we said that if we have a point P on a terminal angle of an angle theta, okay, so we can draw a perpendicular line to the x-axis. So we create a right angle triangle, and we said that this side is x and this side of the triangle is y, and that is r, because if that arm keeps rotating, actually it creates a circle in that Cartesian plane, and the radius of that circle would be r. And we said that sine theta equals y coordinate over r, cosine theta is x coordinate over r, and tangent theta is y over x. Okay, how about if the radius of this circle is 1? Okay, If the radius is 1, then that circle is called unit circle. If that is the case, then we get y over 1. So we get sine theta being y. How about cos theta? So cos theta equals x over 1, and we get cos theta equals x. Okay? And let's look at this point now, coordinates of that point. Okay? So those are x and y. Oh, we just said that x is equal to cosine theta for a unit circle. Then we can write these coordinates as cos theta, and y coordinate is same as the sine theta, and then y coordinate is sine theta. So instead of xy, I can use cos theta and sine theta. Okay, and tangent theta is still y over x. Okay, now we can also say that if y is sine theta and x is cos theta, tangent theta is also equal to sine theta over cos theta. And you're going to use this information later on when you're doing proving identities. Okay, so this unit circle is very helpful when we are working with quadrantal angles. What are quadrantal angles? Those are the angles their terminal arm on axis, on x-axis or y-axis. So 0 degree, for example, is on positive x-axis. 90 degree is on positive y-axis. Okay, so now to calculate the cosine, sine, and tangent ratio of those quadrantal angles, actually I'm going to use a unit circle here. Okay, and we said that for the unit circle, radius is 1 unit. So if that is the case, so the coordinates of this point would be x coordinate is 1 and y coordinate is 0. So here we just said that if we have a unit circle, x coordinate is cos theta and y coordinate is same as sine theta. So if we are working with 0 degree, if you are looking at the 0 degree here, so then this 1 is our cos theta and this 0 is our sine theta or sine 0. Okay, so we can say sine 0, cos 0. Okay, so then sine 0 degree is 0 and cosine 0 degree is 1. How about tangent? Tangent, we said that y coordinate over x coordinate. So 0 over 1 gives you 0. Okay, so let's look at 90 degree. For 90 degree, we are here. So the terminal arm lies on the positive y-axis. So the coordinates of that point would be x coordinate is 0 and y coordinate is 1. Again, x coordinate represents the cos theta. So cos 90 is 0. Y coordinate represents sine theta. So sine 90 is 1. And tangent is y over x. 1 divided by 0 is undefined. So tangent 90 is undefined. So let's look at 180 degree. So for 180 degree, the terminal arm lies on the negative x-axis. So what are the coordinates of that point? X coordinate is negative 1 and y coordinate is 0. Again, this is a unit circle. So each distance here, right, the radius is 1 unit. So this is negative 1 and 0. Again, the first coordinate represents cos theta. And second coordinate represents sine theta. Okay, so sine 180, 0, cos 180, negative 1. So tangent theta, y coordinate over x coordinate, 0 over negative 1 gives you 0. For 270, the terminal arm lies on negative y-axis. The coordinates of this point here is x coordinate 0, y coordinate negative 1. So sine 270 is negative 1. Cosine 270 is 0. Tangent is y coordinate over x coordinate, negative 1 over 0, which is undefined. And finally, for 360, so we make one full rotation and come back to x-axis. So 360 is here. Okay, so this is 90, 180, 270, and 360. So that point again has coordinates of 1 and 0. So the ratios for 360 is same as trigonometric ratios of 0. So we get 0, 1, and 0 here. Now you can look at handout F and textbook questions to practice what you have